Hello everybody, welcome back. Today we're looking at 7.2 properties of graphs of quadratic functions. We're going to look at the example number 1. It says the following information was taken from photos of a volleyball player bumping the ball. When did the volleyball reach its greatest height? So we have the time as the x-axis. Time is always going to be the x-axis unless otherwise stated. It's the independent variable. And then we have height, which is the y variable. That's going to be the vertical axis, and that's given in feet. We have some times and some heights. So what we have is called the vertex. All right, so the vertex, that's the point at which the quadratic reaches its maximum or minimum value. Okay, so again, it's maximum or minimum value, and in this case, remember we talked about opening upward and downward. This opens downward, so its maximum value will be right here. So that would be what's called the maximum. And it's a minimum when we have a quadratic that opens the other way. We saw yesterday when it opens upward. So it takes the shape of like a U. Next we have what's called the axis of symmetry, and that's the line that separates the two-dimensional figure, so this parabola, into two identical parts. Now sometimes it's not going to look identical, and the reason it's not going to look like it's identical is because you don't see the whole part of the graph. So it basically cuts it if you wish in half right at its vertex. Okay? So for example, a parabola has a vertical, it's going to be a vertical axis of symmetry as it passes through what I mentioned before, its vertex. Okay. So I'm going to draw that. I'm going to draw this curve and show you this on the Desmos program. So I've replaced that graph with the axis of symmetry. Axis of symmetry is a vertical line that passes the parabola right to the vertex. The vertex is up here. Okay. So the volleyball reached it. So to get that equation of symmetry, it's not that difficult. What we do is we'll take the two x values right here that have the same y value and at the point, and then we'll take the average, right? So these heights are both at 8. So if we average these two times, that'll give us the x value that we need. So to do that, I'll get the equation here for you. So axis of symmetry is equal to, and remember, you just pick a point that has the two of the same y values. So I picked the ones that are closest to the vertex right here, and we add the two x values together. Okay. And we divide them by 2. So 0.50 plus 0.75, and then we divide that by 2. This is going to equal 1.25 divided by 2, which is equal to 0.625. Oh, 0.625. Okay? So that's how you calculate the axis of symmetry. You take the average of the x values that have the same y value. So you could have used 0 and 1.25. You could have used 0.25 and 1. It will all give you the same value because it's symmetrical. So the volleyball reaches its greatest height at 0.625 seconds is the answer to the first question. And I just showed you how to calculate that here. Maybe I'll put that ahead before we answer the question, obviously. And then the estimated height, so estimate here, it's about 2.3, right? And we're going to learn how to calculate that as well, but the estimated height is about 8.3 feet, approximately. Okay? Now, if I can get it pretty quickly with the Desmos, I'll show you. We'll go back to our Desmos program. So if I just click on the vertex there, it gives me those values, which is pretty neat, right? So there's the X and there's the Y value. So 8.3 was a good estimate, right? So I'm going to use that graph now that we know how to find it. Take this one out and I'll put that in there for us. Okay? Perfect. And that's it for the first example. Let's look at example number 2. It says some children are playing at the local water park. The water jets spray water from the ground. The path of the water from one of those jets forms an arch that can be given by the function f of x equals negative 0.12 x squared plus 3x. Again, this is just notation. Or what we can do is, and this is the same, just another way of writing it. That's called function notation. And we could just put a y here if we wanted to. And it's the same thing. So this is actually what you're going to have in your calculator. So maybe that'll help you. But again, this is just function notation. X represents the horizontal distance, and y, or f of x, or y, is the height of the sprayed water, so the vertical distance. Okay? And there we have a diagram here, okay, to help us with this. So the maximum value is the greatest value of the dependent variable. And remember, dependent variable, I have a variable there, sorry. So the dependent variable, and remember, that's the y-axis, right? Right? So remember that, that's y. Okay? Independent is x, and that's the horizontal distance here. So what I'm going to do is I'm going to show you how to calculate this to get those x and y values from the original function. So there it is there. I'm going to show you how to do this on the graphing technology in order to fill out this table of values. I'm going to make it easy for you. Okay? I'm going to show you how to do that using a table of values. Or a Desmos program. Either one will work. Now the 2.5, you'd have to plug those in. But I'll show you how to do that on a graphing calculator as well. So let's open up our graphing technology. I'm going to clear. I'm going to put that equation in. So again, I'm going to clear this. So it's y equals negative 0.12 x squared and then we're going to add 3x. We're going to graph this, and you'll notice a lot of the functions missing. So you're going to change your window. All right, we're only interested in the positive, so we can make our x min 0, or x max. We're going to have to make it bigger. Obviously, it wasn't big enough, so make it 25. Try 25. Scale, you can just leave it 1. If you make it 5, then it'll just see where the lines are, and I'll show you what I mean by that in a minute. The y values goes high as 20, so we'll go 20, 0, and 20. And again, you just play with this. The scale will go up by 5s. So I'll show you what that is on the graph in a minute. We graph it, and there's a beautiful graph, what it looks like. Okay? Remember, these are going up by 5s, and we went to 25, so this is 5, 10, 15, 20, 25. And this one going up by 5, so that's 5, 10, 15, 20. I'll show you how to do that in the graphing calculator. Okay? So that's going to represent our sketch, what we did before. we want to figure out that table of values. There's a couple ways we can do it. So we can do one. If you want to get your whole number values or your integer values, you can hit second function table, and it'll give you 0, 1, 2, 3, 4. But you'll notice we had some decimal values that we had to look at, right? So this will only fill in a few values for us. It'll fill in like 0 and 5, 10, right? So we can take those. So 0, 0. And 5 was, go back and take a look. 5 is 12. 10 we can calculate. 10 was 18. 15. So we just scroll down on our graph, press the down. We get 15. 15 was 18. 20 was 12. And 25 back to 0. The ones in between with decimal values, I can show you how to do that in the graphic calculator as well. So you can hit second function calc. You can calculate a value, so hit the first 1, 1. And if you put an x value in, 2.5, it'll give you the corresponding y value. Hit enter, and that gives you 6.25. You're probably seeing a pattern. Oh, 6 decimal, what did I say? 7.5. And then you do the same thing here with that. We'll do it again. So second function, trace, which is calculate, with the value 1. And then we put that in and we get, let's put in 7.5. And we get 15.75. Put in 12.5, which is up here, it's already given. 18 decimal. Let's do it. Let's just double check it. So second function calc. Value, and we put in, what was it, 12.5, 18.75. The book ran at 18.7, I'm not sure why. And you see a pattern here. If you were to predict that this one would be 15.75, you would be correct, and this at 6.75, you would also be correct. All right? So, to answer some of the questions here for the graph, it says the maximum height is, and we calculate that at 18.75 feet. You see that from the diagram. And that's at a horizontal distance of 12.5 feet. That was the x value. And how far can the water reach? So that would be the farthest distance from back to where it goes. It can reach the horizontal distance of 25 feet. Right? And that's back when we get to right here in the diagram. Right? So this is the path of the water. It can go a horizontal distance of 25 feet and a vertical distance of 18.7 feet. All right? So that'll be it for this video. In the next video, we'll come back and we'll do example 3. Again, just some calculator work there, and talking about some of the characteristics and the properties of graphs. All right, so thanks for watching, and we'll talk again soon.